All right, we are closing in on the last part of the review. This is going to be the application or word problem. So this goes back to our formulas that we knew at the beginning of the chapter. So it's talking about a car. You own a 1935 Packard 120 that has an original price of $980. That's my starting amount. Appreciated at 5.1%. So that's going to be 1 plus. And remember, if you can't remember how to do this, you're going to do it over 100 and you'll get 0.051. So what I'll probably do is just use 1.051 right from the get-go. So writing a model is going to mean like at the end, it's the starting amount, which was 980, my growth factor, which is bigger than 1 because it's appreciating for however much time. That's the model. What is the value, meaning I need a number? 1980. So you have to kind of look at how long that is. So you'd say, well, 1980 minus 1935 is going to be 45 years. So I use my model and say, if it starts at 980 and it's gaining value at this rate for 45 years, what's its value? And so in doing that on my calculator, I got 9,190 and about 70 cents. In what year will it be worth 55? So that's going to be at the end. It would be 55,000. At the beginning, it was 980. And then what I don't know here is time. So this makes it exponential. So I have to get the power part alone. And to get the power part alone, I have to divide by the 980. So then I end up with about 56.12. And then to solve a power problem, I need to rewrite it as a log. So log of the thing raised to the power goes over here, and then the other number lands here. But again, I need my calculator to find this for me, and so I end up typing it into my calculator as log of the 56.12 over log of 1.051. So when I did that, I ended up getting 82.5 years later. And so I take my starting year of 1935 and I add 82.5 years to it. And I ended up at 2017.5. So in the year, halfway through the year 2017, that would be the year when it's worth 55,000. Okay, now we're in mashed potatoville and the initial amount of people is 12,000. It's increasing at 3%. So 3% divided by 100 will be 0.03. Since it's increasing, I'm going to add that. So my model is going to be the initial amount, starting amount, then my growth factor, which is bigger than 1 because it's increasing over time. Now, current means we're starting in 2023. Okay, then it says, what will it be in 5 years? Oh, so I'm actually just going to plug in 5. I don't have to figure out how far off it is. It's telling me that's a 5. So when I put that 5 in there, then the population should be 13,911 people. And this is not in millions or anything. That's just how many there are. When will, so this is going to be a T, it double. Okay, so if it started at 12,000, it's going to end at 24,000 if you're trying to make it double. So not surprisingly, when you divide this over, you get 2 because you're trying to make it double. Now, this is a power problem, as they always are in our word problem. So I'm going to go ahead and rewrite it as a log. Log, whatever is the base, power, and other number. So I go to my calculator and I let it split that up for me and find the answer. And when I do that, I ended up with, what did I end up with? 23.4 years. And it actually says when. So again, I guess I would take the now and I would add those 23 years. So in 2046, later in 2046, that's when. It doesn't really say which year. So in this one, I would accept either 23.4 years from now or the year 2046. Okay, after drinking a caffeinated beverage, the percent of caffeine in your bloodstream reduces. So this one's going to be 1 minus. And if I change 15% by dividing it in half, I'll get 0.15. So my growth factor actually is 0.85, which ends up being less than 1 because it is getting smaller. So you drink Mountain Dew with 54 milligrams of caffeine. Write a model. Okay, so what's going to happen at the end is you're going to have the 54. It's decreasing. That's why that's less than 1 over time. How much is left after 1 hour? So I just plug in a 1 to that problem because that's 1 hour later. And when I did plug in a 1, I got 45.9, and I'm looking back, it's milligrams. What time is there 27 left? So now 27 is going to be at the end. 54 was the start, and I'm working backwards to time. So I need to get the power part alone. So like usual, I divide out this value. That lands me at a half equals 0.85 to the t power. Then I'm going to need to write that in log form where the base goes in the basement, power over here, and the other numbers there. So then I'll be doing log of 0.5 over log of the bottom number to find out what t is. And when I'm doing that, I'm finding out that t is 8.5 hours. But it says what time. So since I started at 7, I would take 7 plus 8. This is kind of confusing actually, because if I start at 7 plus, oh, hang on, I think I was looking at my answer key and copied the wrong one, sorry. When I did this, I actually got 4.3 hours. So I'm going to take 7 o'clock, which is when they said you drank that, and I'm going to add 4.3 hours. So during like 11-ish, it says approximately what time. So around 11 o'clock or a little after. Okay, B, you drink a Red Bull with 80 grams. So that's my starting amount. And that's a 2. And again, this is using the same rate. So that's my model. At what time will there be 20? So I'm going to actually go ahead and put a 20 in as my last number. Oops, it says write a model, so here they just want the equation. So to solve this one, I'll put a 20 in. Then I'm going to have to do what I always do, get the power part alone by dividing by 80. So now I'm going to be at 0.25 equals 0.85 to the t. That's going to be log of whatever the base is equals the power and then my other number. So into my calculator, I do that thing where I break them up, and it's going to find out that that is going to happen. This is where the 8.5 came from. Sorry, 8.5 hours later, but you drank it at 2 o'clock. So if you add 8.5 hours, that's going to be 10.5. So at 10:30, because that's half an hour. So at 10:30 at night, it will wear off, or it'll be at the 20. Okay, you drink a 5-hour energy shot with 200 milligrams. That's my starting amount, and it's still caffeine, so it's still using this. After how many hours will there be 100 left? So you're looking for it to come down to half of what you started with. So by dividing out the 200, I'm going to end up with 0.5 equals 0.85 to the t. I've actually done that one before, but I'll do it again. So this is log, or log apparently. This is log base 0.85 equals t of 0.5. Splitting that up on my calculator, I'm going to do the log of 0.5, and I'm going to close that out and then divide by the log of 0.85. Sorry, I was looking at something. So I'm getting 4.2-ish. Okay, and then that's actually 4.3. It actually just says how many hours later, so that would be about 4.3 hours later. Sorry, I'm looking at my answer on the answer key, which does not seem right. 1, that's right, log base. Okay, So that's hours, sorry about that. After how many hours is there? Just one. So you're gonna end with one. You started with 200.85 T. So I'm gonna divide out the 200 because, just like always, I need that power alone. So I'm gonna divide out the 200. So 1 divided by 200 gives me a kind of small number, 0.005. So log base 0.85 of 0.005 equals T. So I'll split that up in my calculator as the log of 0.005, close that down, and divide by the log of 0.85. And I'm getting 32.6 hours later. Okay, grand finale. The length of a tiger shark can blah, blah, blah. So they're giving you the formula. L is length, T is age in years. So how long is the tiger shark at 8 years? So they're giving you the time. So the length will be 337 minus 276 e to the negative 0.178 times 8. This is a 100% calculator problem. And so you would just multiply it into your calculator. And I got 270.6 centimeters. Here it says how old is it when it is 173 long. So you're actually going to be working backwards. This one's pretty takes a little doing because I got to get this part alone. So I start by taking away 337 and I end up with negative 164. But I still have negative 276 times the power part. So I'm going to divide by negative 276 because I have to get that power part alone. So when I do that, I had like 0.594-ish. That shouldn't have a 0 there, sorry. Okay, and now I'm going to rewrite this as a log. So it would technically be log base E with the power over here. But log base E is just ln. So I'm going to do ln of 0.594. And I'm going to have negative 0.521-ish. And to get T alone, I'm going to divide by the number that it's getting multiplied by. So finally, I'm going to take that answer, divide by negative 0.178, and my time is coming out to be roughly 6.7 years old. All right, hope that helps, guys. Bye. Okay, JK. When I did this last part, hang on. I didn't get this. I was hurrying. So what I meant was 0.178 T. When I divide this over to the other side, what I actually got was that T was equal to 2.9 hours. So let's go with that. Okay, now goodbye.